Welcome to lesson 4.5, where we're going to talk about concavity and the second derivative test. So first, let's introduce the idea of concavity. If a function is concave up, it means that if you draw any tangent lines, so tangent lines on the graph, they're all below the graph. So that's concave upward. Another shortcut to remember, as I call it, the smiley face. If it's concave up, it looks like a smiley face. Also means, this is a big one, your second derivative is positive, greater than 0. That's concave up. The second derivative is positive. Next, I have a graph with this shape, concave down. And this is where all our tangent lines lie above the graph, aka frowny face. So this is where your second derivative is negative. That's concave down. Now, one other thing to notice on this, if it's concave up, at the bottom of your concave up, you usually have a minimum. And if it's concave down, at the top of your concave down, you usually have a maximum. So here's your little memory device, the smiley face and the frowny face. Concave up is positive, so smiley. Concave down is negative, so it's a frowny. Now, one last thing. A point of inflection is where the graph has a tangent line and it changes concavity. So right here at 0, 0, we go from concave down, frowny face, to concave up, smiley face. So because we changed concavity from down to up, that is a point of inflection where the concavity changes. So if I had something like this on a sine wave, that right there would be a point of inflection where we're changing from concave down to concave up or vice versa. So let's start with this first problem. We're going to look at this graph right here. On which intervals is the graph concave up? So if I look at it, let's see, concave up is my smiley face. So right there is going to be concave up. That's going to be concave down. That's a frowny face. Right there is going to be concave up. There's a smiley face. This right here is going to be neither. That's a straight line, so it doesn't have any concavity. And then right here, that looks like it's concave up. And then right there is going to be concave down. So I've got 3 smiley faces, 3 concave up. From -2 to -1, that's this first one. From +1 to +3, there's the second one. And from +4 to +5, there's our last one. Okay, let's do concave down. Now this time we're looking for frowny faces. So here's a frowny face, that's concave down. Smiley face, straight line, so that's neither. There's a smiley face, there's a frowny face, concave down. So we've got from -1 to +1 and from 5 to 6. And then it says on what intervals does it have no concavity? That's going to be from 3 to 4. That's our straight line. Linear does not have concavity. And our points of inflection, where it's changing. So I've got right there where it changes from concave up to concave down. Right there it changes from concave down to concave up. Right there it doesn't change from up or down because it's from up to none. So those don't count. And then right there it changes from concave up to concave down. So I've got 3 possibilities here where it changes concavity. But I have to pay attention to number 1. It also has to have a tangent line, aka the derivative exists, aka no sharp turns. So right there is not a point of inflection because it has a sharp turn. The derivative doesn't exist. Right here and here, those are not sharp turns, so those would be my points of inflection at 1, 1, and looks like that's 5, 1 would be my points of inflection. Okay, so that's a brief first introduction to concavity. In the next video, we'll talk about it a little more in depth.